Hey everybody, Dr. Nelson here. In this video, I'm going to show you how to determine if a set of ordered pairs represents a linear or a non-linear function. Alright, so what I want you to do is for the first couple pages of your notes, copy down what I write down, and then there'll be some problems for you to try on your own, and then you can see how you did at the end. Alright, so over here where it says characteristics of linear functions and tables, there's really one important thing that you need to write down here, okay? And that is the rate of change, between points, must be constant. All right, so the rate of change between the points must be constant. Okay, so over here, let me give you an example of one that's linear and one that's nonlinear. All right, so take a look at our x and y values. Okay, notice we go from -1 to 0 to 1 to 2. So as we go down the table, notice that the values are increasing by 1. All right, so from -1 to 0, it's +1. From 0 to 1, it's +1. From 0 to 2, it's +1. Okay, if we continue, there'd be a 3 down here, and that'd be a +1 as well. Now, take a look at the y values. Here, it's going from -1 to 0, and that's a +1. Here, it's going from 0 to -1, and that's a -1. All right, here we're going from -1 to -4, so that's a -3. So notice this is not consistent. It's different every time, okay? That means that this is a non-linear function. All right. Now take a look at the next one. Here we're going from -2 to -1. Just like before, this is increasing by 1. From -1 to 0, this is increasing by 1. From 0 to 1, this is increasing by 1. But look at the y values. All right. Notice this time we're going from 3 to 1, which is decreasing by 2. Then we go from 1 to -1, which is decreasing by 2, and then -1 to -3, which is decreasing by 2. All right, because it's always decreasing by 2 for every change in the x value, right? We know that this is going to be linear. All right, let me show you one more thing about this. We can also go from this point to this point. So the change from -2 to +1, right, is a change of 3, right? So now when I go from this value to this value, the change from 3 to -3 is 6, right? Now when I do 6 divided by 3, notice the change again is a change of 2, okay? So again, it's consistent every single time, all right? So take a look at the next page. And in this case, we know that the data, all right, represented in each table is a linear function. All right, so what we're going to do is we're going to fill in the missing values. So let's see, when we go from -1 to 0, notice that's a change of 1. When we go from 0 to 1, that's a change of 1, which means if we keep this pattern going, this next value has to be, that's right, it has to be a 2, okay? Now here, we're going from -2 to 0, so that's a change of +2, which means this one's going to have to be also a +2, right? So this value is going to be 2. All right. Now look at the second table. Here we're going from -6 to -4. All right. So that's a change of +2. All right. Which means to get this value, I need to add 2 to -4. So that's going to make it a -2. And here we're going from -11 to -7. So that's an increase of 4. We go from -7 to -3. That's a change of 4, right? So what do I have to do to get this one? All right, that's right. You have to add 4, right? So -3 plus 4 will give us a +1, and there it is. All right, so what I want you to do, I want you to pause the video and try the your turn problems, and then when you're done, hit play, and you can see how you did. Good luck. All right, welcome back. Let's see how you did with these problems. Okay, so for these two tables, you had to determine if the data represented in each table represents a linear or nonlinear function. Okay, so for the first one, let's look at the change of the x values. So if you notice, we're going from 1 to 2, and then 2 to 3, 3 to 4, 4 to 5, and 5 to 6. So these are changing constantly by a plus 1. Let's take a look at the y values. Notice we're going from 1/2 to 1, and then 1 to 1.5, 1.5 to 2, 2 to 2.5, and 2.5 to 3. So this is changing constantly by a positive 1/2. Because it's consistent, we know that this is going to be a linear function. All right, for the second one, we have x values and y values. So let's take a look again at the change of the x values. So it looks like this one is also going to be a plus 1, right? And then, let's see, for the change in y values, this one's going to be a plus 3. But notice, look at this right here, okay? When we go from 10 to 12, that's a change of plus 2. Because that's not consistent, we know it automatically is going to be nonlinear, okay? If I tried to graph this function, it wouldn't make a nice straight line. All right, let's take a look at the second page. This one's a little bit trickier, okay? So the change in x values, all right, when we go from 1 to 3, that's a change of plus 2. Now the change of y values, we're going from 2 to 10, that's a change of plus 8, okay? So if I do 8 divided by 2, right, that gives us a change of 4, right? So every single time the x value increases by 1, right, the y value is going to change by 4. All right, so here we know that this is increasing by 1, okay? So I need to add 4 to the 10, and that'll give us a 14. All right, now notice this time this is increasing by 4, right? And like I said before, we know that when the y value increases by 4, the x value is increasing by just 1. Now this one, we know that the x value is increasing by 3, right? So remember, for every increase of the x value by 1, the y value goes up by 4, right? So I need to add 12 more to this. So that's going to make that a 30, all right? And now notice this one, the change is a plus 12, right? So if I do 12 divided by 4, that's going to be a change of 3. So if I add the 3 to the 8, that gives us a 11. And there it is. All right, how'd you do?